suggests that it's a study that's really worth looking at on your own. This is one of the real major findings of the Rose study. The horizontal axis is a Human Development Index, and I don't know if you can see it, but African and poor countries are on the left, and the rich Northern European countries are on the right. The vertical axis is scores on questions about positive impact, positive attitudes towards science on a 5-point scale. And what you can see here is that the less developed a country, the better the kids like science and the more they think of it. And the more developed the country, the less they're interested in science. This is essentially a universal finding, and all developed countries are worrying about fewer kids being interested in science, in studying science, in becoming engineers. Japan is worrying about it. It's not just us. All of Europe is worrying about it. So that makes me think that it's not just something about the way we teach in a particular country. It's something more fundamental. Where would the US be on this? This is a similar question, just for one question. I like school science better than most other subjects, and the countries are grouped with Africa at the top, then Asia, Southern Europe, Eastern Europe, Northern Europe, Japan, and Scandinavia. So here's Japan, and the blue dots are boys and the red dots are girls. So what are the patterns you notice? In Africa, girls are just about as interested as boys. Some of that's true in the poor areas of Asia, India, Bangladesh. But as you come down to the more developed countries, there's less interest overall and more of a gender gap. Why is this? I don't know, but I have some hypotheses. This is, I would like to become a scientist. In Uganda, 80 to 90% of boys and girls would like to become a scientist. In Norway, it's between 10 and 20%. Why is this? Now, here is one piece of data that does include the US. It's PISA 2006. I haven't updated this yet with the most recent PISA report, but it says this is the percentage of students agreeing with statements about the value of a career in science. And here, you can see that the USA is actually somewhat better than other developed countries. 36% of kids in USA see the value of a career in science. That doesn't necessarily mean they aspire to it or like science. So what is this kind of anti-science feeling in these other countries? This is my hypothesis. This is a little graphic of the last century in science in the West. The invention of the automobile, of electronics, the development of vaccines that have vastly increased the human lifespan, solving Fermat's last theorem, unraveling the mysteries of DNA, landing on the moon, developing new medicines, nuclear power with all its pluses and minuses, and understanding the theory of tectonic plates. You look back on that, and that's just a huge set of accomplishments, and that's just one little smattering. There are lots of other things that aren't shown there. If I were a kid looking back at that, I would think, man, how are we ever going to measure up? This is tough. What's there left for us to do? And against this, I put a saying of my father's, which is inscribed above the RNN research building at Intel headquarters in Santa Clara. Don't be encumbered by history. Go off and do something wonderful. Shed that weight of history. The last time we really tried to get kids interested in science was the Sputnik era. And the challenge at that time was, our enemies, the Russians, have put a satellite into space. They're beating us in the space race. We need to step up as a country and go forward for freedom, and we need to conquer space. Well, there are two elements of this. One is the sort of nasty, xenophobic, warlike part of it. But part of it is the huge imaginative dream of space, supported by movies, supported by comics, supported by science fiction. A place for the imagination that could involve kids like the Rocket Boys in this picture. But what have we been saying to kids in the past few years should be our reason for them working hard and studying in mathematics and science? Well, the leaders have been industrialists, Lou Gerstner, Bill Gates, reports saying things like a nation at risk, tough choices, tough times. The message we've been giving kids is study math and science, become engineers for competitiveness. Work like this, so you can become this and make me rich, me the industrialist. And I just don't think that's a very inspiring message. I think what we should be telling kids instead is study science and math to save the world. A few years ago, the American Academy of Engineering put out its list of grand challenges in engineering. Now, not all of these are relevant for kids or speak to them, but some of them I think do. And here's a list of them. Solar energy, fusion energy, carbon sequestration, finding ways to save the world from climate change, access to clean water for people all over the world, engineering better medicines, understanding the brain, managing the nitrogen cycle, and these others. I don't have to read them to you. There's a couple of things in here that seem attractive to kids. Virtual reality, that kind of seems like fun. Actually, I'm going to focus on this one, fusion energy, for a moment. And the reason is my son, who's 14 and just entered freshman, first year physics, as a summer reading assignment had to read Physics for Future Presidents, which has a lot about nuclear power in it and nuclear bombs. And he told me afterwards, this is really cool, I understand nuclear bombs. He explained to me the difference between A bombs and H bombs. Okay. And then he said to me, this really makes me kind of want to become a physicist so I can understand and figure out fusion energy. The idea that there could be an unlimited source of energy and power, and that could be discovered by someone in this generation, is inspiring to kids. And this is a topic that can be studied in high school. It's kind of interesting. There's the whole cold fusion story, which is a story about mistakes in science and how they are rectified. Carbon sequestration options. I think this is a topic that can be studied well in middle school as part of a science class. And kids can look at trees and forests. They can look at questions of pumping carbon under the ground, how you do CO2 capture. It's a kind of integrating concept and one that I think kids can relate to. Clean water is something kids can relate to at every age. This is something that has to do with worldwide justice, economic justice and opportunity. And it's also something that you can experiment with in the classroom just by making simple filters. And I just want to mention as a resource the series of books from the Museum of Science, Engineering is Elementary, which is which are 20 books, each presenting a problem, an engineering problem that a kid faces in some part of the world that can be solved using the engineering process. These are accompanied by activities and experiments, projects that kids can do in school. Now I know I don't know that there are any elementary teachers among you, but it may be something to share with colleagues. And there may be ideas in these books that can be adapted to the middle school or later. Well, that was just a little discussion of engineering problems. In mathematics, there are the Millennium Prize problems. And these are more problematic because they're hard to translate into language that kids, teachers, or I can understand. They have names like the PNP problem and the Riemann conjecture, and there's some others. I'm going to find them so that I can read them to you and sound as I know of something. The Swinnerton-Dyer conjecture. It's the Birch and Swinnerton-Dyer conjecture. Sorry. The Yang-Mills theory, etc. So these are not as easily, these challenges are not as easily adaptable for kids. So I went and asked an applied mathematician friend of mine for some ideas, and here are some that he came up with as grand questions in mathematics that can be shared with kids, that could be understood on some level by kids. How can we decide if a problem is too complex to solve? How can we make an unbreakable code? This is very important, obviously, when we're all giving our credit card numbers online every day. This book, In Code, was written by